a quiz over Q6. Another one problem quiz after we get through some of this. So here we go. We have already discussed pieces of this earlier, actually in chapter 1. Can anybody remember about a vertical asymptote? Max?
Aren't they usually like square? Like X?
Well, you can do square problems. We'll do them after we practice a few of these. But to have a vertical asymptote, it doesn't have to be square. What is that? I don't think it's coming from out there. Is this
That.
All right. So vertical asymptotes come from your denominator. So my vertical asymptote is x equals 3. And since I'm going to need to remember that, I might take a little note over to the side. Vertical asymptotes, that's a vertical asymptote, vertical line up and down. Vertical asymptote comes from the denominator. And since it's x minus 3, my asymptote is at 3. If it had been x plus 3, my asymptote would be at negative 3. Okay, think of that as like a parentheses there. They're not going to be there, but you can think of them. Okay. Horizontal asymptote. Anybody remember where those came from?
Numerator.
Not from the from the numerator and the denominator. The box in. That right there is your horizontal asymptote. So since I have 1x over 1x, that is just 1. So my horizontal asymptote is at y equals 1. Now, where does the vertical asymptote come from? Denominator. Where does the horizontal asymptote come from? Boxes, right? Now I'm going to do intercepts. In other words, where do I touch the x-axis and where do I touch the y-axis? The numerator gives you your x-intercepts. Where do you think with that numerator, where do you think my x-intercept is going to be? Negative 2. So at negative 2, I'm going to have a dot, which I'm going to label just exactly like I have been doing all along. If this had been, think of your test you just took. If this had been a parentheses on the test, wouldn't you put a dot at negative 2? Same thing. Where do the x-intercepts come from? The numerator. Now I keep repeating myself in hopes that you're writing this down because you're going to have to be able to remember it. So one more time. Vertical asymptotes come from the denominator. Horizontal asymptotes come from boxing, comparing the x's. My x-intercepts, my dots on the x-axis, come from the numerator. And then my y-intercept comes from letting x be 0. So to get our y-intercept, we're going to let x be 0. So what happens in my problem if I put in zeros for x? What do I get? 4. What do I get on the top? If I put a 0 in, I get 2 on the top. What do I get on the bottom? Negative 3. So what's my y-intercept? Negative 2/3. You guys, come on. Shake that, whatever's going on in that head, shake it out. Put a 0 in here, you get 2. put a 0 in here, you get -3. 2 over -3. That is your y-intercept. The only other thing that I need to put in my picture are the holes. Who remembers anything about holes? This problem isn't gonna have a hole. Why not, Max?
Because it's not a parabola. Oh, no. Because they're both going down.
They don't cancel.
Nothing cancels, oh my gosh, good job. Remember, the only way to get a hole is to have a problem, and it would have to be bigger than this, a problem where things cancel. So if we had a problem that looked like this, and we factored it, and we got this, see that right there? That would cause a hole. And a hole is nothing more than an open dot in your picture. This problem does not have any holes because obviously these don't cancel. And the only way you can get a hole is if your problem cancels. Okay? So, now, this is where I am. This is what I have. And I have to somehow draw a picture from this. See these 2 dots right here? They're going to be connected. And the shape I'm going to get looks like that. Have you ever seen anything that looked like that before?
Yeah, in
It's one of our BFFs.
in our BFFs.
Which one is it?
Square root.
It's the reciprocal function. And this is a reciprocal of sorts because it has an X in the bottom. The BFF that looked like that was that one. Okay? Okay, now tell me what you remember. It had this piece, but what else did it have?
They had
It had another piece opposite it, like diagonally from it. Now, you don't physically have any points plotted up here, like you had these 2 down here, but these 2 were enough to get me started because these are gonna have a piece down here and a piece, if they have a piece down here, the other piece will be up here. If they have a piece up here, the other piece will be down here. Okay, done. That problem is finished. Let's look at the next one. Let's see what you remember. What do you remember? Let's start putting stuff in. You can put in things in whatever order you want. The things that have to go in are the vertical and horizontal asymptotes, the x-intercepts, and the y-intercepts, and any holes that you might have. So tell me what you know about that guy.
you gotta switch it. The denominator? How do you graph that? It's 1 would it be -1 plus no -x plus 1?
That's what it is, yeah, but you be careful thinking about it like that.
Is 0?
What? No?
Horizontal?
It's what? Somebody said it. 1. Trey is right. Your vertical asymptote is at x equals 1. Now, why is it at x equals 1? Kids, your vertical asymptote is whatever makes it 0. So this was 3, because 3 minus 3 is 0.
Yeah.
What makes this 0?
1.
1, not 0. 0 would make it 1. I don't want it to be 1, I want it to be 0. So that would be a 1. That's your vertical asymptote. Notice how I label it. Okay, what else can you put into our picture?
Box.
Okay, now when we box, be careful, because you're boxing in the x's, right?
Yeah.
So what do we have? We have
Negative.
x
Negative.
over negative x, which is going to make negative 1. So your y, or your horizontal asymptote, is y equals negative 1. Is this probably going to have any holes? No. The only way you're going to have holes is if you factor and cancel. Obviously, this problem's too small. There's no factoring and canceling to do. All right, what about intercepts? How do I find intercepts? X-intercepts come from the numerator. So look up here, where do you think the x-intercept is? 2.
2.
And then how do I find my y-intercept? Plug in 0. So 0 minus 2 is negative 2. 1 minus 0 is 1. So where is my y-intercept? Negative 2. And that's all we've got. So based on that, we need to be able to draw our picture. Do you have enough for you to draw it? I think so. Remember, it's going to be a reciprocal function. And since you have a dot right there, doesn't that mean I have a thing down here like this? And I got the same thing up here.
Is it always?
Yep. For a problem formatting like this, yes. And obviously there are other things. All right, how do we feel about that, okay?
Yep.
All right, let's step it up a notch. Look at C.
That's a double factor.
What do you think you're going to do first with letter C?
Factor.
You're going to
Factor.
factor that. X squared minus x squared minus 4, x squared minus 9. How does that factor?
Plus 2 negative.
Plus 2 minus 2 plus 3 minus 3. And do you notice right off the bat that nothing cancels? So we have all this, but there still aren't going to be any holes because we didn't get anything to cancel. Alright, so tell me what we would have then. No holes. What do we have?
No holes.
No holes.
Two
I'm gonna have 2 vertical asymptotes.
One at.
They come from the denominator, so I'm going to have a vertical asymptote at negative 3 and a vertical asymptote at 3. Alright, so remember, your wise old teacher suggested that you write down where these things come from. Where do vertical asymptotes come from? The
Denominator.
If there's 2 things in the denominator, then guess what? You have 2 vertical asymptotes. Alright? What's next? What else?
Horizontal.
Horizontal asymptote. And where does it come from? Boxing in right here, right? This time it's x squared over x squared, but that doesn't matter. It's still
1, no.
1. Perfect. Now what? With what place? What do I want to do now?
Make it 0.
x-intercepts come from? They come from the numerator. So when I look at my numerator, I'm gonna have -2 and +2. Those are my x-intercepts. They come directly from the numerator. Where does my y-intercept come from?
Zero.
I plug in 0. Now, I like to plug in 0 in the original problem because it's less math for me to do. But I can plug in 0 here and have to put it in all those places. If I plug it in here, 0 minus 4, 0 minus 9. So I have -4 over -9, which is 4 nines, which is like half, not quite half, so it's right in here. And you already told me that there are no holes. Okay, you already told me that. So this is it for important stuff. This is our intercepts and our asymptotes. So somehow you gotta figure out our picture for this.
Go this way and then that way.
Well, let's focus right here. What do you think's going on in between these vertical asymptotes? What do you think's happening here? Doesn't it look like a parabola? Those points look like a parabola to me. Now I know what you're thinking. You're thinking, that's not a reciprocal function. You're right, because it's got more stuff. It's bigger. This is a reciprocal function. But as soon as you put in more stuff, you get more graph. And we happen to have gotten this nice little parabola. We aren't done though. We have done the part between the asymptotes. What do you think's happening out here on this side? Any idea what's happening out here in this space?
It's this one. You still got the line.
No, but sort of. It looks like this. Very rare. It looks like this. So that is part of the reciprocal thing. We'll talk about that more in a second, but that's what it looks like for us.
Will you do it to the other side too?
And we do exactly the same thing on the other side. Alright, so this is the picture. I'm gonna explain something to you here. I want you to kind of stay awake, pay attention. When I am graphing something, or you are graphing something, that you really don't know what it looks like, you have no way of knowing what that looks like. One option that you have is always to set up a T-chart. Remember those things from back when you were younger?
Yeah.
And plot points. The more points you plot, the better your picture will be. I didn't need to do that this time because I know that the two possible shapes, and this is true for all of them, okay? On the outsides of your picture, I'm not talking about this, but on the outsides of your picture, you're gonna have that shape right there, or you're gonna have this shape right here. Those are your only two options. No matter how big your problem is, on the outside, whatever's happening out here, it's gonna look like that or that. I knew that it wasn't gonna be this one, because if it were this one, what would have to happen right there? There had to be a dot, like I had here. Do I have a dot there? So it can't be that one, so it had to be that one. And by the same argument, over here, it's either that or this. Always, guys, always. Inside can be weird stuff, but outside's gonna be that or that. I can't cross yes, I don't have a dot there, so it has to be that one. Well, yeah, it could be down here. It's not in this problem because it can't cross, but you could have that. Yep, yep. That would be unusual because usually asymptotic behavior, what's happening on the asymptotes, see how this is going down, then the other side is usually going to be going up. But it's possible to have down now. All right, well, the fun just continues. Let's look at the next one. These are all rational functions. There's drawing pictures. We just did the last segment, got pictures of polynomial functions. These are rational. Okay, boys, are we paying attention?
Yeah.
Yes, ma'am.
All right, what's step one? We're gonna graph this one. This is letter D.
Factor.
Yeah,
We have to
factor.
say factor.
So the top is gonna factor as -5 plus 1.
Yep.
Now be careful on the bottom. Right away, do you see a GCF?
Yeah.
So take out that 2. And then what am I left with?
X minus 2, X plus 2.
Yep. Now, that 2 that I took out stays. Alright, that's part of the problem. But now we are factored. Will this problem have any holes?
No.
No. Because even though we could factor all over the place, nothing cancels. If nothing cancels, then we don't have any holes. Alright, so tell me what I do have. I have what? What, 0, 2? Tell me what that is. What do I draw there? Vertical asymptote. I have 2 vertical asymptotes. I have one at 2 and one at -2. What else do I have? Horizontal? Where is my horizontal? With the original problem. Watch it, it's not a 1 this time, where is it? Not a 2. 1/2. The horizontal asymptote is at 1/2. Why is it at 1/2? Because we have 1/2. Alright? What else do I have? Look at your numerator. What does your numerator tell you?
Your X's.
You got your x-intercept at 5.
5 and
5 and 1.
5. And another one at -1 of this 2. On opposite sides, yeah, that's different than last time, that's okay. Alright. How do I get my y
Put 0.
intercept? Put in 0, and again, you can put in 0 wherever you want. I think it's easier to put it in the original, because that's a 0, that's a 0, all I have is -5. That's a 0, all I have is -8. There's really no math to do. If you put the zeros in here, you're gonna do it. So that's 5x Nice idea, right? One of those shapes.
Yep.
Because there's a dot right there, this one is gonna look like this. Now let's go to the other edge, the other side, over here. I don't have any points over here, which is a clue that it's gonna be up here. I told you, I hope you're listening, that on the ends of the picture, the right side and the left side of the picture, you're always gonna have one of those. This one had to be down here because we already had a dot. We have to connect that dot. This one had to be up here because we don't have a dot. Are you still with me? Now I gotta figure out what in the heck is happening in the middle. Do that again, Arian. It looked like a lot of movement
It's not
around.
about going like this, like the one, maybe one.
Well, clearly, these two dots have to be connected. All right, your points are going to be connected. So I'm guessing that looks like that. Now be careful. Our last problem was a parabola, and that would look like this. It cannot be that. Somebody tell me why it can't be that. Because I don't have another dot. So it's not doing that. Well, boys and girls, if it's not coming down, it must be going up. So now in the middle, instead of having a parabola, I have a cube in there. I have a cube in there.
So it can go through that line, but can't go through.
Very great question. Great question. So, Mr. Lee says, wait a minute, can we cross that line? And the answer is yes. You can cross a horizontal. You will never cross a vertical. Verticals are untouchables. Horizontals get crossed a lot in the middle of the picture. So don't panic about that, but never cross a vertical. Like, see these two dots right here? I would never connect them, because in order to connect them, I would have to cross this vertical line.
Would it be a hole across the vertical?
You can't cross a vertical.
Would it be?
It never happened. When you approach a vertical asymptote, you're gonna shoot up, you're gonna shoot down. There's no other behavior than vertical asymptote. If there were a hole there, it wouldn't be a vertical asymptote, it would be a hole. And it would have a different kind of behavior. So no. There aren't many things in that we can say absolutely that's one of them. Absolutely not. We don't touch it. Okay, next, let's see if we can figure out the next one. By the way, your calculator will graph these, so when you are not using the calculator right now, but like on your homework or something, if you want to check to see if you're right, you can type it in and your calculator will let you know if you're right or not.
Back to the bottom.
Back to the bottom. And I would definitely factor the top if I could, wouldn't I? But I can't. So this bottom. And how does the bottom factor? Minus 3 plus 1. I heard somebody back there say it. Thank you. Good look. Does anything cancel? No. Therefore, there'll be no holes. Do I have any asymptotes?
-5.
In fact, I have two of them. I have two verticals.
Three.
I have a vertical, not at -5. My vertical asymptotes come from my
Three there.
denominator. So I have a vertical asymptote at 3, and a vertical asymptote at. Now, something's happening at -5. What is happening at -5? It's an x-intercept. X-intercept at -5. Yeah, anything else?
It would be, what about the
Horizontal asymptote?
Yeah.
Where does that, what?
0.
0. Chase Nichols, why is it 0?
Because you can't have the top lower than the bottom.
There's no x squared on the top. See that? I can't box because there's no match. There's no x squared up there. So that means exactly what he said. That means your horizontal asymptote is at 1 equals 0. Now back to Mr. B's point. I already have a point there, don't I? That's okay. That's all right. Don't panic. It's okay. All right. What else do I have? Y-intercept. And where will it be? How do I find that? Put in zeros. So again, I'm going to do it on the top. If I put in a 0, my top is 5, and my bottom is -3. So 5 over -3 is like -1 2/3. And you will have a baby calculator, so if you need to do a decimal in order to plot that, that's fine. It's -1.67.
Then we do the, like that,
Where are we doing it?
the left side.
Over here?
Yeah.
Brian says, look here, folks. I got a dot right there. Here's my question for you, Brian. Do I know whether I'm purple or blue? Do I know
Wait, let me
which
think.
one I
Cause there's
am?
gotta be a separate one with the other guy.
Wait.
Oh wait, no, I was gonna say if you do the little cube thing,
Is it purple?
Which one or the other? This board has no idea.
Is it purple?
I have no idea. I don't know. How could I check to see?
right?
I'm gonna plug in a point. This is, that's -1, so I'm gonna plug in -2. I'm gonna plug in -2. So if I plug in -2, let's see, I'll do it here. What's -2 plus 5?
3.
3. -2 minus 3.
-5.
And -2 plus 1. Now, I don't even care what it equals. I just want to know, is it positive or negative?
Positive.
That number is positive, which means we are purple. Because this is a positive point right here. So we are purple. Now, it doesn't stop here. Does it bounce or go through there, do you think? It's gotta go through. And this is freaky. It comes down for a while and then it comes back up because it has to have that kind of shape. That is the shape it will always have. So it can't keep going because then it'll have the wrong shape. So it comes down, it passes through, then it comes back up and follows on out. This is a hard problem. You can handle it, babe. what do you think's happening in the middle here?
Like this.
So Brian thinks it's, I'm gonna dash it. Brian thinks it's like this. Where's the rest of it think?
Oh no.
Why can it not be that?
There's not another
Oh,
one.
there's not another
another
point.
dot.
You just cut it off then on the right side?
Don't cut it off. You got some kind of a parabola shape down there.
Why is it a
I
parabola?
thought you cut
What
it.
else would it be? Tell me what else it would be. I mean, I know it's not this, right? Because it can't cross.
Just be straight.
Or it's straight line there. It can't cross either one of these.
Straight up.
It can't go up because.
Oh, is it the
Oh,
like this, like this?
Well, that's kind of a parabola when you put a V on it. These do not have sharp edges, so it's a rounded thing. But remember, you got a point down here. You have no points here, so the curve can't cross over. It has to stay down here. And there's no shape to draw other than this one that will keep it all underneath.
So it's parabola.
Yep. Last part, what's happening over here. I don't know, boys and girls, but it's either this or this. Would you agree with me?
Yeah.
It's either gonna be positive or negative.
Plug it in.
I believe it's positive, but I don't know. I'm gonna check. So I'll plug in, what is this, 3? I'll plug in 4. So 4 is gonna give me 9 over 1 times 5. Is that positive or negative?
Positive.
Positive. That means I'm up here. That's our hardest problem for sure. Yep. I never saw it yet. It is not. I didn't know what it was, top to bottom, so I dashed them both in, but it is. That is the answer. All right, next.
This works everything I expect.
Yeah, right. I still wish. Okay,
Factor.
factor. How does it factor?
X minus 4, X plus 1.
Very good on top, x minus 4, x
You got a
plus
hole.
1. How does it factor on the bottom?
X plus 1, X minus 1.
Whoa, Brian is correct. Does everybody see we have a hole? This is our first problem where we've been able to cancel. All right, so let's go ahead and take care of that right now. Where will the hole in this picture be? The hole will be where x is -1. Because that is the factor that I canceled out. Now I need my y coordinate, because this is going to be a point, I'm going to plot on my graph. I need the y coordinate.
Positive 4.
I don't know, how do I find
You
it?
plug it in.
I plug it in. So if I plug in -1, I'm going to get -1 minus 4 over -1 minus 1. I'm plugging in -1, and don't do that in the original. You have to plug it in the reduced one. It won't work in the original. So it looks
5 over
like
2.
5/2.
Yep.
That's what it looks like, which is 2.5. So -1, comma, 5/2. And I have a nice big open circle at that.
Then we could do the y axis for the y, which is 1.
Talking about the asymptote?
Yeah.
Your horizontal asymptote is y equals 1. Y is the horizontal asymptote, y equals 1. Because of this right here.
Yeah.
Alright, what else do I have? I have a vertical asymptote. If you have a denominator, you have a vertical asymptote.
At
And the
1.
vertical asymptote is at
1.
1. Verticals are x equals across the x-axis. Alright, how about intercepts? Where's my x-intercept? Oh
Zero
my
in?
gosh, where
Zero
do I get x-intercepts from?
Numerator.
Numerator, what's my
Would it just be,
numerator? 4. We should not be sitting there staring at me. X-intercepts come from the numerator. Look at it, it's 4. How do I get a y-intercept?
At 0.
Plug in 0. So if I plug in 0, I get -4 over -1, which is 4. Oh, wait, we do that here. 1, 2, 3. Now, this picture only has one vertical asymptote, right?
Yep.
So it doesn't have a middle piece, it just has a left and a right. And remember, the lefts and the rights always look like this. So, don't you see this here, guys?
Yep.
There's that point right there, and then what about over here? Same thing?
Yeah.
So the whole is connected, but it's an open dot, but it's connected to the curve. There we go. Easy peasy. All right, last one, G. All right, G, here we go. Wow, this is a mess. All right, here we go. What should we do first?
Factor out the 2 up top.
Can I
Oh,
factor
no, you
out the
can't.
2
You
on
can't.
top?
You can't. Uh-oh.
No.
So then it's gotta be like 2.
So I'm gonna have to factor it with the 2. But I'm a grown up, you're a grown up, so you can do this. Check this out, guys. I'm gonna put a 3 there and a 1 there because I gotta get a 3. And what happens here? 6
6x?
and 1.
Yeah.
I need
Oh,
5. So -6, +1.
Oh, that's way
We're getting
better.
-5. You learned how to do that when you were in 7th grade or something, so you just need to practice it. And how to do it. How's the denominator factor?
X minus 3, X minus 1.
-3 minus 1.
You got a
Voila!
We got a hole.
We got a hole.
So before I forget, case I forget about that hole, so I'm gonna graph that first. Look what canceled out.
So then that's one of them.
So the hole will be where X is 3.
Yeah.
Look what canceled out. So the hole will be where X is 3.
And then substitute back in.
And I'll put it back in, and it looks like this time I get in 3,
7 over 2.
7 over 2, which is 3.5. 3, 7.5. Okay, so that's done. Now I can focus on this. Tell me what you notice. What do we got here? A lot. X equals 1. That's exactly right. I have a vertical asymptote at x equals 1 because vertical asymptotes come from my denominator.
Denominator.
All right, what else do I have?
Count our x's. Box.
Box. So it looks like I'm gonna have a horizontal asymptote at 2.
2. Yep.
How about intercepts? Now, we know the x-intercept comes from the numerator, right? Right?
Yeah.
So if that had been just x plus 1, you would say
-1.
-1. Put a 2 out in front of it and it's -1/2. Because 2x plus 1 equals 0. When you solve that, you get -1/2. If you're ever in doubt about where to put a dot, set it equal to 0 and solve. That will tell you where to put it. So x-intercept is at -1/2. How about my y-intercept? -1. How do I get a y-intercept? I plug in zeros. Now that's it. We need to be able to sketch this thing, so see this little point that's sitting up there all by itself?
That's gotta go like this.
Doesn't that tell me that it
Yep.
looks like this?
Yep. And then
And
the
then
other
see
one.
these two right here? They are connected,
Yep.
so it looks like that,
That's it, right?
and that's it.
That's just a lot of steps.
It's a lot of steps, and that's why when you look at your homework, you see that it's only 2 problems. Right, so that homework will be due on Friday. If we have a chance, we might do one of them in class, but I'm not gonna promise that because I don't know. Do I see you tomorrow?
No.
Okay.
Nope.
So, Friday, right, Friday, I'll see you on Friday, we'll do a practice of this, and then on Monday, you'll do one of these for a break, okay? So I would suggest, take a look at that homework, practice it a little bit on your own. And then, next time I see
Copy
you,
that.